Fun fact. This is like my 5th frickin' time making this video because, one, the Apple Pencil got possessed by the devil and would just stop working, and then I'd have to start over. And then I just tried resetting the iPad, and apparently you have to turn on the microphone every time you reset it, so I just made 20 minutes worth of videos, and there's no sound to them. So, we're going to do this one last time. And I will not be doing it after this. So we're all just going to cross our fingers that this goes well. And it might go kind of fast. But you know what? We've learned this material before. You've had a full year to let the math just sink in. So we're just going to hope for the best. Oh, mercy. Okay. Radicals. Breaking them down. Okay. Did we talk about index before? Where did that come from? I just did that, for heaven's sakes. Okay. Index, you know the kind of root it is? Well, to break down square roots, I know you've done this tons of times, so this should be child's play for you. We're just going to casually break down these numbers. And I'm circling groups that match the index. So this is like a square root, so there's an invisible 2, so I'm circling groups of 2. If there's a cubed root, I'd be looking for groups of 3. A 2 comes out, a 3 comes out, and that poor sap inside gets left behind. Pirate code, whoever falls behind gets left behind. Okay, let's talk about multiplying. Well, let's talk about adding radicals first. So let's say I have like 6 square root of 3 minus 7 root 2 plus 5 root 3. Okay, we can add coefficients of like roots. Think of it as like terms. So instead of x, you have a square root 3 there. So I see 6 root 3 and 5 root 3. Those can combine to be 11 square root of 3. That 7 root 2 stays the same. So now when we are multiplying them, we're going to start simple. Because these roots have the same index, meaning they're the same kind of root, we can just multiply their insides together. So this would be like 7 times 5 times 2, which is square root 70. If I had something like a cubed root of 2 times a square root of 2, well, no dice. You can't do that. Unless I switched them back to exponent stuff, but let's just not worry about that. Because you know what? I wrote the final, and I know what you should focus on. Okay? So let's look at binomials. Negative 2 plus root 5 times 7 minus root 11. Distribution still applies here. Thank goodness, some rules never change. Negative 14. Negative 2 times a negative gets me a positive 2 square root 11. Plus 7 square root 5 minus square root 55. Well, would you look at that? We don't even have any like terms, so we're donezo. Cool. Okay, let's look at dividing, and this is where the fun comes in. 5 over square root 2. What I really hate, and what math hates in general, is roots in the denominator, aka an irrational root in, well, all roots. I take that back. An irrational denominator. Not okay. No roots in the denominator. Nonezo. We were donezo, now it's nonezo. So a lot of you, when we first learned this, you're like, oh, we're going to square it because that gets rid of the square root. You're wrong, because squaring a number changes its value, okay? 3 does not equal 3 squared. 2 different numbers. So I can't just go squaring something. No, we got to multiply this by root 2 on the bottom because, hey, the definition of squaring is to multiply something by itself. So by doing that, oh, squaring a square root, those cancel and I just get 2. But we're going to be real smart here, and I'm going to put root 2 on top as well, because you know what this is equivalent to? Equal to 1 does not change the value. Would you look at that? 5 times root 2 is just root 2. And now we have ourselves a proper answer, like top hat, monocle, proper answer. Okay? Let's do something a little bit more challenging. Let's say I have -2 over 4 minus square root 3. Let's bring back a word you're afraid of. Conjugate. Basically, you're going to switch the middle sign of a binomial. So if I have 4 minus root 3, it's going to be 4 plus root 3. And the really important things with conjugates, the middle terms cancel, but most importantly, it rationalizes your expression, meaning we will be left with no roots. So if you have an irrational binomial, meaning root, and there are 2 terms, you are going to multiply by the conjugate. So 4 plus square root of 3, 4 plus square root of 3. Let's see what happens. On top, we're still going to distribute. So I get -8 minus 2 square root of 3 on top. On the bottom, let's see, 4 minus root 3 times 4 plus root 3. I got a 16 plus 4 root 3 minus 4 root 3. Negative root 3 times positive root 3. Well, the roots cancel, and I just get a -3. Hey, look, the middle terms cancel. So I get a 16 minus 3, which is just a 13. And there we go. I could possibly look to reduce this if all 3 of these numbers shared a common factor, but they do not. Therefore, we are done with that. Okay, last reminder for you. Complex numbers. In the format of a plus bi. I? What was that? Oh, you remember. The square root of -1, of course, because it's imaginary. Negative numbers don't have square roots. And please, for the love, order matters here, people. It has to be real, then imaginary. Okay. With this I equals -1, what happens if I square that? Sorry, I equals square root -1, I square it. Oh, well, Jill, look at that. So important. Okay, here's the nice thing. I'm going to start with adding and subtracting, so let's go -4 minus 2i plus 7 plus 20i. Adding and subtracting complex numbers is just like combining like terms. Best day ever, because we're so good at that. -4 plus 7, that is 3. -2 plus 20, that's 18. Wham, bam, goodbye, we're done. Okay, let's multiply the same ones. -4 minus 2i times 7 plus 20i. -4 times 7 is -28. -4 times 20i is -80i. -2 times 7 is -14i. -2i times 20i is -40i squared. Whoa, now wait a minute. I squared. I know is -1. So this is like -40 times -1. Oh my goodness. Look at that. All it did was switch signs. Plus 40. Hey, look, more like terms. -28 plus 40. Get 12. And then -80 minus 14 is -94i. And, we could go over dividing and whatnot, but as the person who wrote the test, I decided to spare you. So as long as you can do those with complex numbers, you should be golden.